So our aim here is to be able to create a circuit which is a little bit more complex than the first one. So we're going to grab 3 switches. And we're going to also put a couple of gates on here. So we're going to put an AND gate here and a OR gate here. And then what we're going to do from there is we're going to put 2 outputs. So let's just put straight outputs on here, another output here. I'm going to wire it up, and you can wire it up in a few different ways. But to get this circuit designed, we're going to go from here, going to go across and from there. But then also going to grab this one, join it, and come that way. And then we're also going to come from here below. And just to make it a bit easier, we're going to introduce a new tool, which is from the miscellaneous section down the bottom, and it's the text tool. And what happens here is with the text tool, if I click on the screen, I can now label that particular piece. So I'm going to do this a few times. I know you can't see the text tool itself, but as soon as you've actually clicked in there, it's helpful. Put in a position, and we're going to label our switches A, B, and C. So that will make it a lot easier when it comes to completing our truth table a little bit later on. And similarly, we're going to label our output X and label our output Y. So the last thing we need to do here obviously is to finish the wiring, connect that up to there, and connect that up to there. Alright, it's just there's a small connection problem there, but now that I've fixed it, by labeling the circuit, it's going to make it a lot easier from our truth tables perspective. And obviously, as the circuits get more complex, it's going to be harder to follow. And now what we have to do is on our truth table is go through all the different possible combinations and look at what happens. So obviously, when all 3 are off, output X is out as a 0 and Y is the same. I'm going to click C, and you can see that Y has now turned to 1. And then we're going to work through all the possible combinations, just as it's drawn for you in the truth table, and writing down the results of each of these ones each time. So I'm going through my combinations. There will actually be 8 possible combinations, and as you learn about binary numbers, you'll discover why there would be 8 combinations when we have 3 switches. And then we have gone through all the different possible combinations now, and each of these combinations should be then written into the truth table so that we can work from there. There's no real deep purpose to this particular one. It just shows you that you can join these ones together and can be quite a helpful little piece of circuit just to build our understandings of how this digital logic stuff works.